Welcome back, class. Today we're going to start looking at variables and expressions. These two items will allow us to start building programs and manipulate data. So before we get into it, let's just take a quick look at the zybook and see what we're going to be covering this week. First off, we're going to start looking at variables. We're going to look at variables and how we can name variables, how we can process variables, how we're going to declare variables, and how we're going to give them names and meaning. We'll be talking about two major data types today, integer data types and floating point data types, probably focusing mostly on integers at this point. We'll talk a little bit about expressions and how we can build the complex algebraic formulas to manipulate the data as we need for whatever the program task is asking us. Okay, so let's dig into this a little bit. First of all, what is a variable? Well, in its simplest form, a variable is a location in the computer's memory to store a piece of data. Now, a piece of data can be just about anything. It can be the score in a game, it can be a person's name, it could be a dollar amount from a banking application, it could be a GPA from your transcript, it could be the letter grade from your transcript. Pretty much anything that we want to use and manipulate in a program is a piece of data. You could think of it as a post-it note, so each post-it note would contain one piece of data. A storage locker where you would put something in, maybe modify it, put it back. Something along those lines. Something where we can hold information for later retrieval and processing. So there are three main categories of items used to store data. First, we have literals. A literal really isn't a variable. It's more of a number, for example, like the number 5. We'll see this in an example in a minute. A variable, which can have its value change over time. And a constant. Constant is similar to a literal in that it is stored in what is called a variable, but that variable itself does not change. Furthermore, we'll be looking at what we're calling primitive data types in their most basic form, things that cannot be broken down further, such as an integer, or a floating point number, or a character, or a Boolean variable, which we'll see in a minute. Later on in the class, we'll take a look at objects and arrays, which are a little more complicated and can have multiple values and multiple expressions to process those values. So in order to use a variable, we have to be able to identify it. So we have to be able to give it a name. So each variable must be declared and initialized. So declaration is the process of creating the variable. Initializing it is the process of giving it an initial value so it can be used in your program. It makes sense that each variable must have its own unique name. Two variables with the same name would lead to lots of confusion. We want to try to avoid names that have been reserved. Each language and each processing system has their own list of variable names that cannot be used. And I'll show you some examples of these as we go forward. Avoid using variables that start with a capital letter. That has a special meaning in Java. Those will be used to identify a class, similar to how we saw in our example program, the class name example. I'll take a look at that right now. I'll bring it up. You can see here's our class name example. It has a capital letter. And here's our variable declaration here. Starts with a lowercase letter. So again, try to avoid using capital letters in variable names. In fact, the compiler will throw an error if you do that. So there is a standard naming convention that programmers tend to follow. Variable names that are mixed in case, meaning like a 2-letter word or a 3-letter word, we'll start with a lowercase first letter, and then additional words start with capital letters. So let's take a look at that as an example. And I'll be referring to our section 35 in the zybook to allow us to demonstrate these things. So this was our program that we looked at last time. I'll probably just leave it here and start modifying it. I'll just delete some of the stuff we don't need for now. And I want to declare a new variable. And we'll get into variable declaration in just a minute. And I can call this variable 1 is a valid variable name, and I'll set it equal to a value of 0. And as I was just talking about, a variable name with a two-word name, let's call it high score. Maybe we're making a video game tracking system of some sort, equals 0 also. So you could see if I want to have a variable with one word, starts with a lowercase letter. If I want to have 2 words in the variable name, it starts with a lowercase, but then the second word starts with an uppercase. Variable name should not start with an underscore or a $sign. Variable name should be short but meaningful, meaning you want to be able to identify what the variable does by looking at its name, but without having it too long that it becomes unwieldy. Similarly, you don't want to have variables that are too undescriptive, such as a single letter or a generic term that we don't know. We can't tell exactly what it means. There are some occasions where you would want to use a single letter variable, and we'll get into those probably more when we get into the looping section in a couple of weeks. So here next are the different variable types that we'll be looking at. There are essentially 4 categories of these variables. First off, we'll start with the Boolean variable. The top one is a true or false variable. It literally contains the values of true or false, and that's it. Those are your only 2 choices. This will be used quite often when we get to the conditional statements and the looping statements. Next up, we have characters. Characters are exactly what they are, a single character. Next up, the next 4 actually, are the integer variable types. And we have 4 different sizes of variable types, such as byte for a small number, and you can see the size range there. Short for a larger number, int for a fairly big number, and long, which is even bigger than that. Finally, we have 2 floating point numbers, floating point data types. Floating point data types are our decimal numbers, our fractional values. So integer data types hold integer values, whole numbers. Floating point data types hold decimal values. Now, while each variable does have a default value, it's best to initialize it yourself so you have control over it, so you know what the starting point is. You don't want to assume anything when you're writing a program. Always code it so you can try to bulletproof it and make sure it's not going to break, and set the initial value to something you expect. Like you may want to set an integer value or a floating point value to a 0. You may set Boolean to true or false, depending on your application. And character you may want to set to a blank value. We're going to focus a lot on integer variables in this video, and we'll touch on floating point and how they can be used. Later on, we'll look at characters and Boolean. Okay, so we know how we can declare a variable now. Let's start looking at how we can assign values to a variable. A variable can be assigned either a value either as a definition or later in the code as needed. So when we declare a variable, we can give it a value. We can give it an initial value when we declare it, or assign it later on by a calculation. We can use simple arithmetic functions that we're all familiar with, plus, minus, multiply, divide. And then this other one here, the %. It's a different kind of division. It's called modulo division. We'll take a look at that later. That does have some very interesting properties and becomes very useful when you're dealing with integers. And here are some simple expressions that we can build. This assigns a variable named x equal to value of 5. This can be read as assign to the variable x the value of a plus b. So if you read it as, instead of equals, assigns the value of, it might make a little more sense than algebra. These are not algebra expressions, but they are algebraic, meaning they follow the same rules, with some exceptions we'll take a look at. And finally, here's another example. A circle circumference equals 2 times the radius times pi. So you can see we have descriptive variable names. We have mathematical calculation. We have another variable name, makes sense what it is. And we have something in uppercase. Oh, uppercase variables have a special meaning. Like I said earlier, they could either be considered a class or they could be considered a constant. So if the entire variable name is in uppercase, it will be called a constant value, such as the value of pi, which we know is a constant value, it does not change, and we can represent it by this variable here. Now, you may be thinking, when do we use variables? Well, there's no real hard and fast rules about variables and usage. You will need them in your programs to hold and store data. The question is, do you want to use them for everything or just some things? I prefer to use them for just about everything. I try not to hard code a single value, meaning typing in, for example, in the prior slide where we had the variable pi, I don't want to have to type in 3.1415 whatever every time I want to use the value of pi. I want to be able to use a variable to represent that. Similarly, let's say I wanted to have a variable that contained the maximum value of a test score of 100. And I want to use that in multiple places in a program. Well, if I later on decide that I want to change the maximum value of a test score to be 90, I would have to go into every place in the code where I had 100 and change it to a 90. But if I had used a variable instead, I would only have to change the variable's value, and then it would take effect throughout the entire program with just a simple change. So some general rules. If you're coding the same number repeatedly, consider using a variable. If you prefer to use, some people like to use variables that only if the value changes. Some prefer to use variables for everything. But a lot of times the decision comes up to your professor or your employer, as they may have different coding standards for their organizations, and when you write code, you need to follow those rules. In this class, we're going to try to use variables for every value. I try not to, like I said, I try not to have hard-coded values in there. It's best to be able to change a variable in a single spot and have it take effect throughout the entire program. Now, we talked a little bit about declaring variables. When we declare a variable, we declare its type. So as we saw in the prior slides, once I declare a variable as an int for an integer type, it is an integer type for its life. It does not change, it cannot change, it will always be an integer. Unlike other languages such as Python, where a variable does not get defined as a specific type, and that type can change throughout the program as necessary. But you may have an instance where you may want to change one variable type to another, and you can do that, but you need a second variable to do so. That's what we call casting. And we'll take a look at casting a little later on. It's a little more advanced than we're ready to look at right now. But essentially, it allows you to take an integer data type and store it into a floating point data type, or vice versa. And here are two examples. So here we have an implicit data type, where we're storing a floating value into an integer variable, and an explicit type, where I'm specifically telling the compiler to do so. Again, we'll take a look at these in a little more detail a little later on. Now, as we start building our expressions, we're going to be following the same rules that we do in algebra. And I've listed out here on this slide here the precedence of operations. And you can see they pretty much follow what we've known from various math classes in the past. Parentheses gets the highest precedence, followed by these unary positive and negatives, your multiplication and division, your addition and subtraction, and then later on, as we get into logical expressions, we have the comparisons, the equal comparisons, logical AND and logical OR. These last two are specifically for Boolean expressions. These middle two here are for comparisons, which will also generate true or false values. And these first four rows are our normal math expressions. You'll see missing here is exponents. Exponents are not listed here in these simple mathematical computations. They're handled a little bit differently through some math functions that we'll take a look at also. Okay, so there are also some shortcuts that we want to take a look at. A lot of times, such as in a loop or something along those lines, you'll be adding 1 to a value over and over again. And you would be doing, if you used the variable x, you would be doing this statement here, x equals x plus 1. And while that's pretty easy to read, sometimes programmers like to get a little cute and fancy and create these other expressions. So we have another shortcut which we could use. It looks something like this, x plus equals 1. And that's just shorthand notation for this expression here. Has the same functionality, it's just a shorthand way of writing it. You can use it or not if you'd like. Sometimes they're helpful, sometimes they're not. Logically, they do the same exact thing. And you can have other shortcuts here. You have plus equals, minus equals, times equals, divide equals. Just shortcut ways of updating a single variable with a value. And as we're looking at shortcuts, there are some other shortcuts that we can use. And you'll see here towards the bottom of the page, we have a bunch of assignment statements, declaration and initialization statements. In all of these, we're using an integer data type, int on the left. In this top section here, the variable we're declaring is the variable y, and we're setting it to a value. The value we're using is, in this case, x plus plus, which is interesting. X plus plus, well, let me take a step back actually. The plus plus or minus minus will either increase or decrease the value of the variable by 1, either before or after the assignment. So, I know that's a little confusing, so let's take a look at it. X plus plus says, assign the variable y the value x, and then increment x. So you see the first half is the assignment, and then the increment. The second line is similar, except first we do the incrementing of x, and then we set y to the value of that computation, which is x, essentially x plus 1. And we have similar expressions for the minus. Set y to the value of x, and then subtract 1 from y. And then the last line here is subtract 1 from x, and then set that to the value in y. And lastly, we have another example here with 3 different variables. Integer I, we'll start it with the value of 3. We'll take another variable, integer variable a, and we'll assign it to I plus plus. So I was the value of 3, and as we stated up here in the rules, we assigned the value of 3 to the variable a, and then we increase the variable I by 1, and we could see here I is now equal to 4. The third line declares a variable b, and we're initializing that to the value of a after it's been incremented by this plus plus. So we know a is 3 from the line above. We increase that to 4, and we assign that to the variable b. So we can take this code, do a little copy and paste here, and we'll put it into our testing compiler. We'll delete these 2 for now, we don't need them. And the paste made it look kind of weird, so let me fix that. Wow, it really made it look weird. Okay, So there, oops, we need a semicolon here. Okay, so here is our example. And I will now, I can run this. Oh, I gotta fix that space. I can run this, and if I do, let's see if there's any errors first of all. No, there's no errors, which is great, but there's also no output because there are no print statements. So let's create a simple print statement after each integer assignment to print out the variable value. So we're going to use the print line, system.out.println, and we'll be a little creative here. The value of I is, and we can put in the value of I. And in this example here, we can put in system.out.println, again, the value of A is, and we'll print A, and then we'll print the value of I is, and we'll print I. And finally, we'll repeat this for the third line. Just when you do copy and paste, always make sure that you update all your variables properly in your print statement. Make sure it doesn't do something incorrect. So we'll do B, and then we'll do A, and let's run it and see what happens. And if we look at our output, the value of I is 3 for the first line, which makes sense because we're doing a simple assignment. If we look at the second output, the value of A is 3 because we assigned A the value of I, and then we increased I, so I went from 3 to 4. And then finally on this last line, we see the value of B is what was A incremented by 1 because we did the pre-increment, plus first. So B becomes 4. And since we increased A already, that's what this statement here is, A also became 4. So we can see in this simple little example here how we declare and initialize variables, how we can print out their values, we can do some simple calculations. Okay, so we have one more slide to look at in this video, and this is the discussion of constants. Now, constants are a little bit different in that we need another identifier to mark them as a constant, and that is this identifier of final. So we declare variables the same way. Here's our int. Here's a CRN for a class. This is a spring class because it's got a 2 in front of it. But here is the CRN, 26108, and final. Final indicates that this variable, once it's set to a value, cannot change. They should be declared in all uppercase, although they don't have to. But by seeing a variable in all uppercase, programmers know that is a constant. So try to follow that convention. It'll make your life a lot easier in the future. And again, as the name implies, once set, they cannot be changed. So let's take a look at this example here. I'm going to just copy it, and I'll go back to our demonstration here. I'll leave this code in. I'm just going to put in another blank line, and you can do a blank line by printing an empty string such as this, just 2 quotes back to back. So I will declare the variable final int CRN equals 26108. Now we'll make it a little more accurate. This class is 98121, and I can system.out.println CRN. And I'll run this, and we'll see it prints everything we had before. Oh, but I have an error. What is my error? Oh, I made a typo up here. It might be a little hard to see, but you could see how the Java functions are highlighted in the blue color, and the print line on line 18 did get that, and the one on 19 did not. So had I been going a little slower, I would have seen that and fixed it. There we go. Print, that makes more sense. And there's the value of our CRN at the bottom of the screen, 98121. Let's say, you know what, I didn't want to take this class. I wanted to take something else. So I can do CRN equals 1, 2, 3, 4, 5. And I'll try to print that value, and I'll put the print statement in, and you could see how I'm kind of lining up the code to make it organized. Always a good idea to try to do that. We'll go into some style guidelines later on. But if I run this code now, there's an error. Error is very descriptive in this case. Cannot assign a value to a final variable CRN. So it's telling me that it recognizes this integer variable CRN has a final value, a constant. It cannot be changed. And I tried to change it. I'm not allowed to do that. Okay, so let's delete this because, well, it's wrong. We can't do it. But I did want to show you one other thing as we're approaching the 30-minute mark. So I'm going to just briefly declare two variables. Int x equals 1, int y equals 2, and we'll do int z equals 0. Now again, try to avoid using single letter variable names. I'm doing it now just for demonstration purposes. So many times you'll see in the algebra world, you'll see something like x plus y equals z plus 3. And that's a perfectly valid algebraic expression. However, you cannot do this in Java. This will absolutely throw an error. I'm going to run it just to see what that error looks like. And it does not like it. It is giving us some kind of unexpected type error. It's telling us it's requiring a variable and it found a value. It just does not know what to do with this. You cannot have two variables on the left side of an assignment statement. You may only have one. It is an assignment from a calculation into a variable. So if I had done something like x equals z plus 3 minus y, which is what you would expect to do if you were doing algebraic manipulation by moving y to the other side, that is a valid statement. And I will print out the value of x to see what we get. Okay, then does that make sense? Z is 0, z plus 3 is 3, 3 minus y is 2, so 1. So yes, that does make sense. Okay, so that is it for the notes for this section. Let's take a quick look at Zybooks and see where we're at in terms of the chapter. So here we are in chapter 2. We have, for this week, I believe we have sections 1 through 14. We have integer variables, we have identifiers, we have some general expression. We have a nice example here regarding some health data. So this shows, we'll just take a quick look at this start here, and it tells us, well, here's our scanner to use variables. But you can see when they've created and declared these variables, they declared but did not initialize, and that's okay. We're going to do the initialization down below. We're declaring an integer type, and it's the user age in years, and we have another integer type, user age in days. And we're using the scanner to get out the value of the years, and we're multiplying years by 365 to get days, which may not be 100% accurate because we know some years have 366, but for this example, it should be just fine. So go through this example, it's a good practice. Again, we have the participation activities, and here's some leap year calculations. And yes, it gets a little more complicated. We can walk through this a little in another video as we get into a little more complicated things. But start with going through your readings, going through some of the participation activities. I will post another video in a day or so regarding floating point, so we can start taking a look at some floating point, as well as some of the division examples. Division and modulo, I want to spend a little time on because that does get a little confusing as well. So start with that. A little more detail to come later in the week. Start your readings, and as always, if there are any questions or concerns, definitely reach out to me on Brightspace or via email. Great, have a great day, and we'll see you in the next